Well, thank you for joining Mining Now, Marcel. Great to have you on the show. How are you?
I'm fantastic. And how are you doing, Jared?
I'm quite well. It's exciting to have you on. You're based in South Africa, is that correct?
That's correct. We're just in Johannesburg area. The little town next to Johannesburg is Randburg, and that's where we're located.
Did process automation? You're the general manager and sales at Process Automation. We're going to cover a lot of what you do. Did it start out as a company that was going global, or did it start really specifically for that South African market? Because now, I mean, I was looking through the countries you serve, and it's definitely global at this point.
Well, we started off in 1980, and I was fortunate enough to start right from the very beginning. So I've been with the company now for 42 years.
Oh, wow.
And the idea behind process automation was, as you probably know, South Africa is a very powerful mining country. We're rich with minerals. We have gold, we have platinum, we have diamonds, we've got, name it, we got it. And so the opportunity was there. One of the most important aspects of doing business with the mines is service. If you can't back up your equipment, you've got a problem. And so when process automation started, the whole focus was to have product and then to be able to service that product. And so we basically looked at what the market needed, and we identified a few unique little issues in the mining industry that we could address. And that was that the service technicians on site, the maintenance technicians on site, they had a host of products that they had to maintain. And it was impossible for them to be an expert on each and every one of them. So we came up, and this is just at the beginning of Industry 4.0, where man started talking to machine. And so we came up with a very clever idea to make the man-machine interface very simple. Now, today that's commonplace. At the time, that was revolutionary, especially in our field. And so we came up with a design where the site technician would read the instructions on the machine and just simply follow those instructions. And that was the opportunity for process automation in the mining industry in South Africa.
Yeah, it's I mean, I was telling off camera, looking through your product line and just the range. We've had companies that have different sensors for different applications on, but just the range that you cover is pretty amazing. Marcel, there's so much to cover today. I'm going to quickly hand it over to Gowdy to give a shout out to our sponsors, and we're going to start to unpack it.
Okay, today we have a full lineup, and first up we have Holly Frontier Lubricants and Specialties, which includes the Petro-Canada Lubricants brand. Petro-Canada Lubricants products and services are proven to maximize equipment performance, productivity, and overall savings. From heavy-duty engine oils to hydraulic fluids, automatic transmission fluids, and gear oils and greases, Petro-Canada Lubricants is committed to delivering innovative solutions that deliver value and keep businesses moving. They have dedicated technical expertise, knowledge, and know-how to help customers in the mining industry operate smoothly with improved equipment, reliability, and performance. To learn more, you can visit them at lubricants.petro-canada.com or contact them at 1-866-335-3369 to arrange a call with one of their technical experts. Next up, we have Savannah Equipment. Savannah Equipment supplies new and used mining equipment around the world, from placer to underground to ore processing plants. They have gold concentrating tables, trommels, and mineral jigs in stock now to take advantage of the high gold prices. You can visit them at savannahequipment.com, where you will find more equipment every day. And of course, we also have Zero Knox. Zero Knox is a global leader in electric powertrain solutions, microgrids, and clean technology. They provide a platform for clean energy technology to come to market through powertrain solutions, development partnerships, and electrification kit solutions for conversions, all powered by Zero Knox. Their mission is to empower communities through sustainable innovation as they partner with some of the world's leading OEMs to solve challenges across multiple continents with cleaner and higher performing technology. Empowering a clean, innovative, and higher performing future without compromise. Learn more at zeronox.com. And of course, we also have CIM. The CIM 2022 Convention and Expo is coming back to Vancouver in person this May. You can show off your products and services in mining technology, digitalization equipments, consulting, and engineering. There's a whole lot of perks waiting for exhibitors at this expo, and it will sell out fast. If you're a researcher thinking about what mining will look like for future generations, this convention is the perfect place to present your technical paper or lead a short course. Visit CIM.org for all the details and book your exhibitor space and submit your abstracts today. Next up, we also have Mining for Miracles. This year, Mining for Miracles is eyeing the completion of its commitment to raise $3.385 million to establish the Cellular and Regenerative Medicine Center at BC Children's Hospital to better understand the genetic cause of heart arrhythmias in children. Get involved or make donations at miningformiracles.ca. And next up, we have PowerZone. When you need a specialized team of world-class engineers for your oil and gas pipelines, dewatering, or any fluid handling needs, you want to visit powerzone.com. In addition to their inventory of rebuilt pumps, motors, engines, they also have an amazing team to design and engineer your systems no matter the challenge. Get in the zone with PowerZone. Visit them at powerzone.com. And last but not least, we have EPCM. Established in 1980, EPCM is a global engineering, procurement, and construction management firm. They deliver comprehensive solutions through EPCM engineering, EPCM automation, EPCM service and supply, and Tecnologías Cobra. Contact them to help you accomplish your goals. Please email them info@epcm.com.
Okay, Marcel, I think what I'd like to do is sort of spin this off from we're going to go back into some of your product lines, but I kind of want to get a sense of the modern mine, and especially from your perspective, because there's so many entry points of where process automation is applicable. So could you just sort of talk about where you see the modern mine now from the perspective of process automation?
So Industry 4.0 obviously was the big buzz. And just one decade later, now, of course, we're at Industry 5.0. Now, that fits in with the modern mine because the modern mines are huge, but they don't have as many maintenance people on the mines as what they used to have. A, B, the mines get monitored off-site as well. Some of the big mines, and I won't mention the name, but they've got a room they call the war room. They can, in fact, in a central location, monitor their entire operation, global operation, and they can drill down, for instance, to a bearing that's running too hot on a mill in central Brazil in the Amazon, and they can, in fact, advise them that there's a potential problem. And we had to fit in with this because it comes down to the machine being able to communicate to the PLC, and via the PLC, it's got to be able to be taken off to their war room. Now, they wanted to take it to the next level, and that wasn't simply being able to measure what's out in the field or to monitor what's out in the field. They, in fact, wanted to be able to do remote calibrations, for instance, on our belt scales. And so they approached us and said they need a system whereby they can monitor. And on some of the installations, some plants at least, we've got over 100 installations. And if you can imagine that the amount of time that is available for maintenance relative to the number of machines that they have, you will see it's impossible. You cannot have one person. And in fact, if you had more than one person, you haven't got enough time in scheduled maintenance to go and calibrate every one of these instruments. So how we fit in on the modern mine, they want to be able to do it all remotely. So when a plant goes into maintenance, they can, in fact, calibrate all 100 machines plus from the PLC. And then there's another advantage as well. They will only identify which one of the scales might be out of calibration, and they would flag those that are within spec will just get fine-tuned and put back into operation. So they are able now to identify the exact one or two scales that might be out of spec. They shoot off to go and put those back into operation again. And this is, as I said, it's all done in parallel. So the advantage that they now have is they can monitor the scales, they can calibrate the scales, and for that, for the same, they can do that for the densities as well. I'm just talking about the scales now. And they are able to log and build a histogram of each and every one of those scales so that they can, over time, have this record. And that is important to them from an auditing point of view. Because when the auditors come to the plant and they want to see the calibration certificates and they want to see the calibration methods used on the instruments, then all of this is recorded now in the PLC. In the olden days, all of that was done by hand and by one person going into the field and doing it instrument by instrument.
Is it, I just want to have an understanding of something. When we're talking about this, is this, now I'm assuming there'd still be a maintenance person around on in this setup. So is this an efficiency? Is there an efficiency focus? There's a safety focus. There's all sort of, where do you fall into most of these buckets, or where, like in this specific example, what is the main goal? Is it lack of damage to the machine? Sort of where is the value add in that particular application?
Well, there's a saying that we have, and that is that you can only manage what you measure, but what you measure must be accurate. So it comes down to metal accounting and the audit trail. So on a mine, if you can imagine, they dig out, let's say a coal mine, they dig out a whole bunch of coal, and this coal gets processed because they've got to remove the rocks, and you just want the pure coal. And so from the coal face, goes into a washing plant. From the washing plant, it gets separated for various ash contents. And at the end of the day, what they've mined and what they ship, that must be accountable. So you can't mine a certain amount and only ship a different amount. They want to know where is the material. The same thing with a gold mine, for instance. They know what they've mined. They know what the grade is. Where's the gold? All of that must be followed and must be an audit trail to be able to do this. And that is where we come in.
One thing I was wondering, going back to that maintenance personnel in the actual field, it must be transformative as well, because it changes the way even that person operates. Now, does it change the skill set? Are you finding when let's say it's a company that's adopting your systems, does it change their like maintenance scheduling, even the skill sets that are required to do the maintenance on the machine, or is it just data driven so that they know when to do it and things like that? If that question makes sense.
That's a great question, because it comes down to preventative maintenance. When you are building up this histogram that I was talking about, that actually allows them to determine very important information. Number one, what is the maintenance interval per instrument, and what consumable portion of that instrument is getting to the end of its life. So if you take an electromechanical belt scale, for instance, there are certain components on that conveyor belt scale that wear. One are the idler rolls. Two, the tachometer. These are in contact with the conveyor belt, and it's a wearing item. So this methodology that we're talking about now allows them to determine what their maintenance interval must be, number one. Number two, it also determines when the life expectancy of that particular item, when that's going to expire. So that means that they can already pre-order long lead items such as the idler rolls,
right?
And they know that in the next, let's say, 15,000 hours or 5,000 hours, whatever it is, it counts it down as they go along, that we're going to have to replace these components. Now, they can order just in time, A, and B, it gets done on a scheduled maintenance day as opposed to an emergency breakdown. That's one of the big spin-offs.
I was wondering too, going back to 1980, when the company is developing and these new products are on you use the word revolutionary at the beginning of the interview. How many of these products are still applicable and have been adjusted to be able to provide data in the way that now from like a war room? Has there been a lot of changes, or are these brand new products, or how is there some of these legacy products that still are still with you today?
You see, in 1980, we only had two outputs. Everybody did. You had a 4 to 20 milliamp output for your rate, your tons per hour, and you had a totalizer that will pulse every time a ton goes over the scale, for instance. And that was hardwired back into the control room, and the control room themselves were hardwired. So from a mechanical point of view, there hasn't really been too much of an evolution, because we kind of hit the mechanical limits many years ago. So it is data. It's exactly what you say. There's so much more information now available. Let's take a Profibus network on a mine, for instance. They would ask us for the GSD file. And as opposed to those two outputs that they used to have, which was the tons per hour, 4 to 20, and the totalizer would be probably a dry contact relay, they now have a list of variables, which is 40 lines. They can now measure the actual belt loading. They can measure the belt slippage. There's so much more data that's now available with the modern networks, and that is being used to fantastic effect. That has been the big change.
Something I'm always curious about is, again, just kind of going into some of the products here, is density measurement and level measurements. Can you pick a couple of those products and just sort of walk me through just how they operate? I think one thing with density is it's something I don't quite understand the mechanics converting to the data of how these sensing mechanisms work. Can you actually start with the density measurement? Because it's quite an interesting looking product.
Yes. So the density gauge, and an interesting point on that, by the way, one of the strengths of our design is we use the same electronic transmitter for a density gauge or a belt scale or a wave feeder for that matter. And we call it the UniPro, Universal Processor. And that's wonderful for the mines, because they've just got there's this commonality of spares. They've got one machine they've got to learn to understand, and they carry spares. It's very limited spares now, because you don't have to carry a spare for each one of these devices. And as I said, and from a training point of view. So the question you're asking is from the mine's point of view is, okay, so the transmitter is the same. The sensor changes. So on a density gauge, for instance, unlike a conveyor belt scale where we're measuring the tonnage, the throughput of the material on the conveyor belt, many mines have got a pumping operation. And so they might be dredging, for instance, and they need to know exactly what specific gravity the slurry is running at, because if they start dredging and they are picking up too much sand or mud, you'll choke the lines. And if they're only pumping water, that's not efficient. So they need a way to determine exactly what the specific gravity is of the slurry that they're pumping. It's also used, for instance, and I'll explain to you how the technology, but it's also used, for instance, on a diamond mine, on the correct medium line that they feed into, let's say, the cyclones, for instance. And so that's where the separation of diamond and rock will take place. So you can imagine it's a closed pipe. So you've got to be able to see through the pipe. So we use a cesium-137 radioisotope that is on the one side of the pipe. And on the other side of the pipe, we've got a crystal and a photomultiplier that actually can measure the gamma, and the attenuation of the gamma is related to how dense the medium is that you're pumping. And then it's just simple math. So what happens is we set the zero when the pipe is, let's say, got water in it, when it's at its minimum SG. And then we calibrate it at, well, we'd like to get 2 points within the range. So let's say it's got a range of 1 to 2. You've got to set the zero at 1. So it's never an empty pipe. It's an elevated zero. So it's a pipe full of water. And then we calibrate it in the range, say 1.8. We'll take some hand samples and we will adjust the gain of the instrument. And then we just got some electronics that just measures it from one level of radiation to a different level of radiation. We linearize that, and that gives you a 0 to 100% signal, or in other words, 1 to 2 SG. So in principle, it's a very simple gauge.
Right. So and that, I think that's maybe the gap, and maybe just clarify this. So there's actually some testing done beforehand so that you can calibrate the machine to then identify, based on the tests, it's calibrated to know that this is essentially what is coming through that pipe, or the density of it based on the prior testing that then matches with the calibration. I'm obviously you're explaining it much better than me. Is that the basic principle then?
It is the basic principle, and the beautiful thing with this technology is it's not limited to any one pipe or any one industry.
Right, that's kind of where I was confused, actually.
Right across the board, we use it in paper and pulp, in diamonds, in coal mines, iron ore. Every one of these plants are very dependent. The quality of their product is very dependent on accurate measurement of the slurries or the correct medium lines. And also, you can't, in fact, you cannot operate a plant without a density gauge. It's just not possible. So what we've done with the density gauge is the same technology as the belt scales. We've got automatic calibration facilities, because equally they would have many of these. A big plant will have 200 of these devices, and it's critical to the plant's quality at the end of the day, the quality of the product, or the accuracy of their diamond winning, for instance. So we can also automate that. And as with the belt scale, we do remote calibrations, and we do the histogram, and exactly the same thing with the density gauge.
What about the going to one, and I think this one stood out for me because my background is a bit of used mining equipment and things like that. So I've seen these block chutes and all that sort of stuff. So I was curious actually about that specific product, because again, knowing, I mean, visually seeing something is blocked is one thing, but how does the actual sensor work? I saw the one in a video, and it's actually like it's on the chute, and it looks like it's been drilled in, and there's some sort of sensor. But then I was thinking, well, depending on what's going through there, then there could be buildup around that sensor, and then it could block it. So I kind of wanted to unpack that one a little bit as well.
Now, block chute detection, first of all, there are many different types of blockages you can have in a plant. So your most simple one is a transfer chute from one conveyor to the other. If you get a blockage there and the material builds up, it's going to build up, and it's going to make contact with the conveyor belt itself. It can rip that conveyor belt, which is very expensive. And of course, from a production point of view, you want your material to flow. You don't want it to be blocked. So that's the simplest type of block chute detector. There are various technologies available. We have an alliance agreement with a company called Hawk.
We've had them on a couple times.
I think you've had them on. Yeah, that's right. They've got some technology there that works very well on block chute detectors. We've got over 100 of them installed on an iron ore mine. But sometimes you've got real tough blockages. For instance, in the cement industry, if you have one of your cyclones blocking, this is at 600 degrees. You can't see inside there, obviously. No other technology can work there. It's not possible. And we developed a water-cooled system whereby we can actually measure a blockage in the cyclones on the cement industry, because they have to preheat the product before they put it into the kiln. And if that blocks, it's such a big problem for them, because they've got to wait days and days for it to cool down before they can clear the blockage.
Mhm.
So they need technology where they can see there's a tendency towards blocking, and they can already take corrective action before they get into that crisis situation. So there are, as I said, and also you can get material that's bridging, for instance, in pits and ore passes underground. There are many applications. So some of them we would use the Hawk equipment, but the same gamma gauge I was talking about for a density gauge, it just gets slightly modified and adapted to measure a blockage as opposed to the density of a slurry in a pipeline.
I see. Oh, okay. Okay. So it's somewhat similar in the technology. It's not the picture of like, there's not a gauge sitting there sticking through all the materials as they pass or anything. It's actually from the outside measuring it.
Yeah, there is some technology where you can have what they call a tilt switch or a tip switch, some people call it, where you've actually got a little probe that would hang inside a chute, and as the material comes up and it goes past 20 degrees, it would trigger, and you would know that you've reached a level. But that type of technology is used for very soft applications like rice or corn or sand or something like that. But when you've got great big rocks falling through there, it'll disappear down the conveyor belt of the rest of the rocks.
I want to move on to a couple other things, but I just want to quickly touch on one more product, and that's the speed sensor that you have. Again, a couple of these products, like the speed sensor, are these fairly new, or has it been 10 years? How long have you had them?
Okay, speed sensors go back as far as the 1960s. They used to have mechanical ones. And then in the 80s, they started getting some electronics in, and they got a bit smarter. So what we did was we've got the basic one that will just tell you a conveyor belt has reduced in speed by a certain amount, and it'll switch a relay, and it'll tell you, boom, that conveyor's now at 80% of its speed that it should be. Otherwise, it can be used just to tell you that your conveyor belt, in fact, has stopped, or the belt might have broken. Those were the simple ones. But some of our clients came to us, especially in the ports, and they said, we've got big reclaimers. And iron ore, for instance, is a very heavy product. And they said, if we start over reclaiming, and if you can imagine a bucket wheel reclaimer, and you've got a collector belt that takes the ore off to the ship, if you start over reclaiming and you overload the collector belt, and that collector belt stalls under the load, you've got a big problem, because you won't be able to start that belt again. So what we did was we said, let's take the technology to the next level. And instead of just having a simple switch that tells you you're already in trouble or your belt has stopped, let's do one that tells you that you've got a tendency towards slipping. So instead of just having a relay output, it gives you an analog output, 4 to 20 milliamp output. So in your PLC or DCS, whatever you're using to control your plant, you set up a little block, and you say the speed should be 1.5 meters per second. That should be the speed of the belt, just for instance. And if you see it slipping a little bit, the only reason it will be slipping is because they're over reclaiming. So then the control loop will back off the reclaimer, the speed will go back up to 100% where it should be, and you've avoided a crisis. So that has been the newest development.
These, one thing that came to mind while you're going through this, you said about the size of the mine earlier, the scale that these mines operate at now. What about the smaller mines? For some of these system, are you working with some of the smaller mines, or these types of applications, because of the data points now and the systems put in place and the control rooms, and I mean, now these big mines having the war rooms and everything like that? Do you tend to work with the larger operations, or is there still a place for the smaller ones?
Well, again, what a wonderful question. We do a lot of networking with Profibus, Profinet, Ethernet. We do all those modern networks. But you're quite right. In South Africa, we've got a lot of very small mines. We call them diggers, some of them in the diamond area. And the guy's got 4 conveyor belts. He's got a tiny little trommel, and he doesn't have any of that sophistication. So the irony is this. We've got the Unipro supporting all these modern networks. And on the side of it, we still got the 1980s 4 to 20 milliamp and relay output. So he still got that on board because that's how he runs his plant. So yeah, we've not missed that opportunity.
Yeah, it's again, in some of my backgrounds coming out of these smaller, the four conveyors and the trommel and those little systems. So I was just curious. I also wanted to ask about those. You mentioned Hawk earlier. Now, do you come in? Does process automation come in as an OEM in some cases, and then I see some stuff that's very clearly branded? Then you're working with companies like Hawks, who are an OEM in their own right. So what is sort of is it all across the board? Let's say you're in a mine in Brazil. Is that all branded, or are you working with a partner there that's setting it up? What's sort of the whole context that you work in?
Okay. In South Africa, we've got a headcount of 240, and we are the OEM of the belt scales, the density gauges, the speed switches, wave feeders. All of those, we are the OEM. And then we've got a few agencies where there's a lot of synergy. They're like-minded people that understand that we're always operating within the same group of companies. It's actually a small world. Our world is actually quite small because you're dealing with the same people all the time, because you're dealing with the BHPs and the First Quantums and the Anglo-Americans and De Beers. So there are many mines, but not that many holding companies. So we have repeat business all the time. And all of that is based on one simple thing, and that is service. Do you back up your equipment? Obviously, are you truthful and honest in your dealings that the equipment that you are supplying will in fact do the job that you promise it will do? And you will get weeded out very quickly if you get caught out that you are, let's say, a company that takes chances. You won't stay in business, not in our industry, not in our world.
No. So
we like to align ourselves with like-minded companies, and we've got an agency for load cells, a company called Scale. It's a French company. We've got Hawk. We've aligned ourselves with them, and we do a metal detector. It's an American company called Tektron. They're based in Florida, Jacksonville, Florida. So we wanted those products just to increase our product basket, because up in Africa, traveling to the mines is not that simple. It's a day or two to get there. It's very expensive. Messing on the mines are at a premium. And so if they can have a single company like Process Automation fly a single technician all the way to Guinea or the Ivory Coast or Ghana, wherever we're working, then he can service a whole array of products. The mines love that. And that is the reason that we aligned ourselves with some companies where we just felt that they've got the same value system as us.
When I'm talking to someone like yourself, you say you've been with them for over 40 years. And I'm wondering, when you say, that honesty and customer service, and I'm always curious, how much was developed? And I mean this on a personal, professional level, but also on a bigger scale as a company. How much of that was developed, and how much of that was natural? Did you have a clear understanding of how to communicate with the industry, and just that transparency you have to have, and how you take in customers' information and all that sort of stuff? I mean, how does that even, can you compare it to, 35 years ago when you were still sort of in the starting stages?
Well, I don't even have a job. I have a hobby. I love doing what I do. I love the relationships that we built. And being the OEM, you've also got this the opportunity to design anything you want because you can.
Yeah.
So we love the challenge when somebody comes to us and says we need a dual redundant Profibus DP, for instance. It was unheard of. Nobody could do it.
I don't know what that is.
Well, we were talking about the networking, and Profibus is one of the networks that they would run in the plant. It just daisy chains all the instruments and brings it to a central, the control room, and from there they can monitor all their instruments. And that's the same network that would do the automation that we were talking about, automatic calibrations and stuff.
Sorry.
But what this mine wanted, they didn't just want to daisy chain on one loop, because if that loop gets broken for whatever reason, and it can be simple stuff, for instance, it can be a truck that drives into a pole that's got cables on them, they break and then you don't lose one, you lose them all. And that's the one downside of networking. So what they wanted to do was two separate loops, loop A and loop B. So if they lose one, they'll automatically switch to the next one. Absolutely revolutionary, never been done before, never been thought of. And they came to us and said, are you able to do dual redundant Profibus DP? So went back to our R&D department, guys, is it possible? Yes, it is. Let's do it. And that is just one of the examples of why we're in business. Obviously, you want to make a living. I mean, you'd be naive and dishonest to say that's not the case. But you also want to do the thing you love, and you want to do the thing that is fun. And it's really good fun to get involved in the projects with the mines, with their research laboratories. So there's no honesty or dishonesty. It's like a team, an effort, where we might be the supplier, but we're working shoulder to shoulder with our clients. And so you're going to get weeded out like this if you are a chancer. It just doesn't work that way.
Do you feel, though, that in your career now, I mean, as you see sort of another generation of coming up, you and I are talking, I'm sitting here in a studio in Vancouver, Canada, and are you able to start sort of passing on that passion and genuine love for the industry? Have you gotten a chance to sort of pass that on to new people in the team that are coming up in the industry?
Well, succession is the heart of any business. You can't take your IP with you. And so we've got active programs to bring the guys up to speed. So what we like to do at Process Automation is we like to start the guys in the service department. All of my sales guys are ex-technicians. So when they go to site, they're not going with a brochure and say, I've got this product, this product. The clients know you've got that product. They know it. What are you trying to do? You're trying to add value to the client's day. What is this product doing for you and for your plant? Is it delivering what you hoped it would deliver? Can we enhance it? Is there more we can do for you? So we don't sell anything. We service the clients, and we share ideas with the clients, and we learn from that for new products or product enhancements. So what happens is these techs that come through, they would, for instance, go to Zambia, go to a copper mine up there, and they would, the senior tech would say to him, won't you please just take one of the newbies that we've employed, take him into the plant, just go and show him how your stuff works, how to take a proper density sample, how to calibrate the scale. That's what my sales guys do. And that relationship they are building with the youngsters that are coming through on the mine. So we, as the old guys, we nurture them, we coach them, we tell them how we did it, what worked for us. And remember, all my clients are just as old as me. They're also coming close to retirement. So they equally had to bring the new guys through the mines and through the process. And our young guys are now growing up with those guys. And we are teaching and coaching them. And it's exciting for me to see how much they enjoy it, how much they love it, because you're adding value to your client's life, to his day, to his job. Because remember, he reports to a boss as well. And if he gets his plant running properly and efficiently and accurately, and he establishes metal accounting like he should, he shines in the eyes of his manager. And that's our job, is to make him shine. And the youngsters are understanding, and they're learning this.
Well, I will say, as someone who's younger in the industry as well, it's getting to make a living, what I'm doing, getting to just sit here with people like yourself who've been in, and so many of my guests have been in the industry for a long time. It's like it's unbelievable actually. It's hard. It's not easy to sit there and talk to someone in your position for an hour, and I get to do it 2 or 3 times a week. Before we transition out or towards the end of the interview, I want to just you hear so much about the mining in Africa. You're specifically located in South Africa, but obviously working across that continent. And I know people, a lot of people that are from that part of the world. But your team, you're on the ground, you're in. So could you sort of paint a little bit of a picture? And I realize it's also very different by country. And so this is a big question. We don't have hours to go through it. But can you just sort of paint a picture of what the mining industry is like? Like you said, like it's expensive and hard to get to some of these mines, things like that. Just sort of that idea that people can see.
Well, in South Africa, it's easy. It's a very sophisticated country. Our road networks are world class. So in South Africa, it's very easy to do business. And we have a lot of EPCM companies in South Africa, the Hatches and the Fluors and the Worley Parsons of this world, the DRA of this world. They're all based in South Africa. So for us to do business in South Africa, very, very, very easy. Access to the mines, very easy. We've got some super deep mines. Impending, for instance, is almost 4 kilometers deep. So we've got some real world-class technology in South Africa in mining. And we have a very diverse mining industry. As I said earlier, we've got diamonds, we've got platinum, we've got copper, name it, we've got mineral sands, we've got everything. And that's fantastic from our point of view, because we learn to adapt our products to all of these different mining operations. Now, when you go further north in Zambia and in Zimbabwe, still sophisticated, easy to do business. But when you go far north, for instance, when you're going up to Mauritania, for instance, you've got mines in isolation. And that's where it's difficult to get to. You will pretty much only get to that mine on invitation, because they've got to fly you in on a chartered plane, for instance. And that's where it gets quite tough. So, in Mozambique, for instance, some of the very isolated mines, you can only fly in, and that's more up north in Africa. But we in South Africa, we're well poised to serve North Africa, because they look to us for service, for backup, for service contracts. So we're very active up north.
How much has the industry changed though in Africa? Because that's another thing you hear, and I'm asking this with no assumption. You hear a lot of the growth of the mining in Africa, and you hear talk about it, but again, it's from a distance. I'm here in Vancouver, so I'm not seeing it. Have you seen, like, the last 10 years? How much has it shifted, or have things changed?
Oh yes, First Quantum have built a huge smelter up at Kansanshi, and that's a massive investment for them. So you are finding the big players like First Quantum coming in, and they all in. They don't just dig holes and take some ore and ship it off to another country, and you buy back the final product. That in the olden days, that is pretty much what we did in this country. You dig a whole lot of iron ore out of the ground, and you ship it off, and you buy the steel back. They are building smelters, and a lot of that has been done now, which wasn't done before, and it's massive investment for them. It's a big turnaround.
Wow, yeah, it's a big shift. It's Marcel. I really do appreciate you coming on the show. It's again, with so many of these shows, these first episodes, it's hard to cover because you cover so much. It's hard to actually. I've had people say, well, almost like, "What are we going to talk about for 15 minutes?" And I'm like, "Well, wait till you actually start the discussion." There's so much to cover. I really do appreciate you coming on, and I hope you come back. I know our company has looked at hopefully some opportunities to actually come to South Africa and do some shows from there. Hopefully, if that is set up at some point, we can collaborate with you to be there. It really would be great.
That would be fantastic. You're always welcome.
Okay, everybody, thank you very much for watching. Thank you, Marcel Barnard, for coming on the show, and Process Automation for sharing so much information about the industry. Go to their website. It's process-auto.com. And you'll see we covered a few products, but they've got a whole plethora of systems in place. So please go check that out. Amazing company. Thank you to our sponsors. Thank you to Gaudi for helping us produce everything. And please, please keep on suggesting guests and putting us in contact with people in the industry, because the scope of what can be covered, we can't even come close in once or twice a week. So thank you for those guests that you've been bringing us as well. We will see you on the next episode of Mining Now.